let's graph the feasible region. Now, we have these inequalities, and we have to basically graph the feasible region by shading, and we also have to find the corner points in each case. Now, these two inequalities, don't be confused. They just basically define the first quadrant, right? Because the feasible region lies in the first quadrant. So let's see, we have this xy plane. As you know, x is greater than 0 is basically this entire region above the x-axis, and y is greater than 0 is this entire region that is on the right side of the y-axis. So this entire coinciding region is the first quadrant. So basically x is greater than or equal to 0 and y is greater than or equal to 0 is just another representation for the first quadrant. Okay, so don't be confused by it. Now, the associated equations are these. And again, associated equations are basically just the inequalities in which these inequality signs are replaced with equal to sign. So we have two equations. Simple. Now, standard procedure, find the x-intercept of the first equation, which is basically just 3, 0, and you get the x-intercept by plugging in y is equal to 0 in the equation. Similarly, for the y-intercept, plug in x is equal to 0, and you get the y-intercept, which is just 0 minus 2. Repeat the same process for the second equation, right? So you get 6, 0 as the x-intercept and 0, 4 as the y-intercept. Now, the test point, to find the result of the test point, you plug in the value of the origin, which is 0, 0, in the inequalities and see if it is true or false. The resultant is 0 is less than 6, which is true, right? So the graph of the inequality 2x minus 3y is less than or equal to 6 will be towards the side of the origin, as when the resultant is true, the graph will be shaded towards the origin. So for the second equation, again plug in 0, 0 in the equation, and 0 is less than 12, which is again true. So it will be towards the origin side, right? Both of the results of the test points are true. Now, here you have the graphs of the two associated equations, and both will be towards the origin side. So for example, you have this as the graph of the first equation, so it will be towards the origin, which means this, right? And for the second equation, it will also be towards the origin, which is this point over here, and so you get this. Now, as you know that we first see what the solution set is. So this does not lie in the solution set, and these do not lie in the solution set either. So this is the solution set, right? This entire region is the solution set. Now, we have to find the feasible solution set, right? So let me just do it with another color, right? So you have this over here, and the red shaded region is the solution set. And now let's just shade the feasible solution set, with blue. So the feasible solution set lies in the first quadrant, which is this here, right? This is the first quadrant. So we will shade the solution set that lies within this first quadrant, and that is this here, right? So this is the feasible solution set. Now we have to find the corner points as well. We already have the corner points O, A, and C. To find B, we just need to find the coinciding point of both associated equations. And you do that by just adding them up as simultaneous equations. You find out that the value of x is 9 by 2. And when you plug in 9 by 2 in any one of these two equations, you can get the value for y, which turns out to be 1. So the point B is 9 by 2, 1.